Okay, you guys, I want to talk today about dealing with numbers that are very, very large and very, very small. So I've got two numbers here. This number right here, the 6022 and all of these zeros, okay, represents what we call a mole, which is the amount of a substance. Okay, this number right here, point, all of these zeros, 91 kilograms, is the mass of a single electron. So both of these numbers are very, very either large or very small and very difficult to deal with. So instead of dealing with numbers with a whole bunch of zeros, what we do is we use scientific notation. Of course. Let's try this again. Scientific notation. Okay. This is useful to manage very large or very small numbers. Okay, before we talk about how to put things into scientific notation, and hopefully this is just a review for you guys, but to put things into scientific notation, we have to know what the form is that we're putting it into. So the general form for scientific notation looks like this. M times 10 to some sort of exponent, okay? This is a coefficient that has to be between 1 and 9.99. It cannot be below 1 and it cannot be above 9.99, okay? This guy right here, this is going to be some sort of exponent, okay? This exponent will be positive with large numbers, and this exponent will be negative with small numbers. With small numbers. Okay, so this is super important to us because this tells us when we are going to stop moving our decimal. And we're going to stop moving it when we get to a number that's between 1 and 9.99. Okay, our exponent, we are going to figure out what our exponent is by how many times we move our decimal. So let's look at my big number. Okay, with a very big number, you usually are not going to have a decimal. You have to go ahead and put in an implied decimal. So with a large number, you are going to be moving your decimal, okay, from right to left. So we are going to move that decimal until we hit a number that's between 1 and 9.99. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can't end there. 21, I can't end there. 22, I can't end there. 23 is where I'm going to put my decimal. I have to have my decimal end here because the number 6.022 is between 1 and 9.99. So I'm going to start with my coefficient, 6.022. I'm going to do times 10. Now my exponent has moved from right to left, okay? So it's going to be positive, okay? So when I move a decimal in a big number, my exponent will be positive, and my exponent is going to equal how many times I move my decimal over. And I move my decimal over 23 times. When I have a label outside of my number, my label is going to go outside of the times 10 to the whatever. So mole. So 6.022 times 10 to the 23rd moles, okay? Or, I'll stop right there. Okay, so that's a large number. So if we are dealing with a small number, again, my coefficient right here, the number that goes right here, has to be between 1 and 9.99, okay? When I move my decimal, this time I'm moving it from left to right, okay? My exponent is going to be negative. Up here, as I move from right to left, my exponent was positive. So I'm going to do the exact same thing. I'm going to move my decimal until I hit a number between 1 and 9.99. And I'm going to keep track of how many times I move it so I know what my exponent is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. I have to end right here. So this number in scientific notation is 9.1 times 10 to the negative 31st, and my label goes on the outside as kilograms. Label always goes on the outside of the times 10 to the whatever. So if I am moving my decimal from left to right, I'm dealing with a small number, and my exponent is negative 31st. If I'm dealing with a big number, I move my decimal from right to left, and my exponent is going to be positive. Okay, hopefully that's just a reminder. You guys are going to have an assignment, very small assignment over scientific notation.